As I mentioned, what I'm going to talk about today is LLMs as a paradigm shift. And it's quite difficult to keep up with all of the stuff that's going on in the AI space. It's happening so fast, and people, of course, don't have a chance to keep up with LLMs as well as crypto. And so I kind of see my role is to like evangelize and transfer knowledge about like what's happening in the LLM space and why they're such a big deal. Just a quick chat about my previous talk. So I talked about the intersection of LLM agent frameworks and crypto agent frameworks, which I think is a really promising area. Crypto is really good at frameworks and protocols, and this includes all sorts of frameworks like agents, DAOs, marketplace protocols. But frameworks need an engine, and we believe that LLMs are the engine and really unlock a lot of utility from all of these existing crypto frameworks that we have that include like agent frameworks and DAO frameworks. And there's a link for the talk if you want to watch it. Everyone is talking about LLMs in crypto, but the main focus is usually around training LLMs, and like in my opinion, thinking about the previous paradigm of AI, which involves training models, updating the weights of the models, all these sorts of things. And I think that what this means is that a lot of people don't understand the paradigm shift that LLMs represent, and that's what I'm hoping to communicate today. So you might have seen a lot of like theses coming out from the crypto space on AI, and one very notable omission was building on top of LLMs. A lot of them had like decentralized training of LLMs, which in my opinion is a little bit backward looking. What we should be doing in crypto is not matching the previous generation of AI and kind of decentralizing it. We should be trying to target what the next generation of AI and decentralize that. So this is what a lot of people think prompt engineering is. This is like a prompt given to Stable Diffusion or something like that, where you have to say Ultra HD 4K to get what you want. And a lot of people think that like prompt engineering is going to go away. I guess my definition of prompt engineering might be a little bit different to everyone else's. I definitely think that these really long prompts with these descriptions are going to go away, but prompt engineering is still going to be really important. And by prompt engineering in this case, I mean like all of different stuff that you can fit in the prompt, like samples of data, approaches to reasoning. You can kind of teach the model how to do things in the prompt, and I think like this part is not going to go away. So like I've just picked out 3 of the really big things that I think are significant about large language models and how they completely change the AI space in general. So there's this new thing called in-context learning. There's an example shown on the right. You can see the input prompt in the box with the blue, and then the model output is showed in the box with the green. So a lot of the time people would just ask a question in the input and then receive an answer in the output, right? But what people learned was that in the input prompt, you can actually give an example of a question and answer. So the one with Roger there is the question, and in the prompt we also give the answer. So this is like us demonstrating what a good question and answer looks like. And then as the last part of the prompt, we ask a question, and it'll provide an answer. Now in this case, it gets it wrong just because the purpose of the figure is to show something else, which we'll see in a later slide. But actually, providing these demonstrations of questions and answers in the input prompts really improves the performance compared with just asking the question. So yeah, this is called in-context learning, giving data demonstrations in the input prompt itself. And you'll notice in this case, this is very different to the way that we traditionally feed data to models. Usually feeding data to models happens during the training procedure when we're updating the weights of the model. Here, the weights of the model are never updated. We just give it data samples in the input prompt. So it's a very different way of feeding data to models that doesn't involve any training whatsoever. And what people have found is that you require much fewer data samples compared to fine-tuning when you use in-context learning. It behaves very different to fine-tuning in general. And this really opens up a ton of possibilities. Like, for example, there's a paper here that I link that says, if you use an LLM locally and you do personalization with in-context learning, so this could be like user data that's local on my laptop. I can personalize the behavior of the language model using this data. It's actually competitive with federated learning, where actual training happens, and it achieves even better privacy. So this is like a massive paradigm shift as far as I'm concerned. Do we even need federated learning all the time anymore? Or can we just use local LLMs that are pre-trained with in-context learning? So that's really significant. Personalization previously needed a full training set, now just a few in-context demonstrations. The second really big thing with LLMs is that they generalize to unseen tasks much more. So in the previous generation of AI, we fine-tuned models, and after we fine-tuned them, if you provide some example that is kind of outside the distribution of the training set, so what that means is like quite different to examples in the training set, it would struggle. But what we find is that as the models pass a certain size, they get much better with data outside the distribution of the training set. And this ability to generalize actually comes from the instruction tuning. So you like train the model on instructions, and then we find that it generalizes to unseen instructions, which is like really, really surprising. The significance of this is that generalization is really important for deployment. Users will always provide a prompt that you didn't have in your training set, and so this is like a really huge unlock for deploying ML in production. The last big reason that I think it's LLMs are a paradigm shift is their ability to do reasoning. Okay, so there's this thing called chain of thought prompting. What you basically do is it's the example is shown on the right. So on the left-hand side, we see an example without chain of thought prompting, and then on the right-hand side, we see an example with chain of thought prompting. So you'll notice that in the demonstration that we show in the input prompt for question and answering, we show it how to like take a step-by-step procedure to answer the question. And just by demonstrating how to do this step-by-step or like chain of thought reasoning, it manages to get the answer right, because you're basically saying is, show your intermediate workings. This ability to reason emerges only in large language models, and people really aren't like fully sure where this ability emerges from, but many people think it's a side effect of training on code. The significance of this is that LLMs are reasoning engines, and this opens up a whole new range of possibilities for building on top of them. So just a quick summary. The big things that LLMs can do that the previous generation of machine learning or deep learning models could do is they can personalize things on the fly with very few examples. They can perform general tasks, and they can even perform reasoning over things. And what a lot of people think is that these abilities mean that LLMs can become the next generation of a computing platform. And the main point that I want to make is that most people, if LLMs are a new computing platform, most people in crypto are still thinking about building a new CPU. In other words, like using decentralized training to create these new large language models. What I really want to push people to think about is, okay, yeah, sure, we can use crypto to create new CPUs, but what about the operating system that lies on top of the CPU? What about this whole new computing platform? How do we actually decentralize that? And this is just a teaser as a very last slide. But I'm working on a white paper at the moment, and it's going to hopefully include a lot of stuff around what a decentralized AI OS looks like. I've been diving into the history of operating systems a little bit. So an operating system is a type of platform, and usually they're built on top of modular architectures. Many different firms, like thousands of firms, can develop different modules for that platform or for that operating system, and they design them to be interchangeable and compatible with other modules. And these become building blocks for the larger system. Platforms are intermediaries between different model producers and system assemblers. And platforms can take various forms like marketplaces, industry consortia, or technical standards bodies. So yeah, this kind of ties in with the like mini conference series, which is about like AI crypto standards. What would standards for a decentralized AI OS look like, and how can we bring everyone together to build this new type of decentralized AI operating system, rather than just training new models, which is still important, but there's a whole new generation of possibilities.
Cool. Thanks for that. That's really interesting. So we have a couple of minutes for questions now. I'm going to check the chat and see if we have any user questions, or viewer questions rather. And if not, I have some things that your talk made me think of. Okay. So yeah, if you want to ask Richard a question, now's a great time. You can place it into the event chat, and I'll read it to him. I'm not sure if he can see them as easily, so I'll just make sure to read them. And then that's also good for our people on the replay, so they'll have a little bit of context. Because sometimes when you watch these replays, you just hear the answer to the question and you don't get to hear what it is. So something I wanted to ask you about is since these LLMs have been going viral, particularly around prompting, I see these like trends in prompting. And sometimes I followed them only to then later learn that I'm crafting the prompt based on like my mental model of how the model will take my prompt and use it. So I'm curious what you think people misunderstand about prompting that that we could do a better job of communicating.
Yeah, I think prompting is still really important. But how, like, a lot of people, when they hear prompt engineering for the first time, they kind of laugh at it and say, "Oh, it's just like, writing Ultra HD 4K afterwards." And that is kind of part of it at the moment. And I think that is the part that might disappear in time. But really, prompt engineering, I think like prompt programming is a better term, because what we're doing in the prompt is we're using different amounts of space in the prompt to get a certain behavior out of the model. So maybe I will allow a certain amount of space in the prompt to show it different demonstrations of how to do things. So this is kind of like personalizing it on the fly. Another one is like I can show it a step-by-step procedure to elicit a certain type of like reasoning behavior out of it and all that sort of stuff. And so I still think it's important to add all of these like kind of details in the prompts, but really prompts are much more than that. It's like a local memory store where you can program the LLM on the fly, I suppose.
Cool. So I have two audience questions. First is from Wes Floyd, who asks, what would a killer app look like for a decentralized AI/LLM operating system?
Yeah, I didn't talk too much about apps. I talked more about the operating system itself, I guess. But I think there's a ton, and usually these look like things that are built with LangChain. For example, like workflows, different LLM workflows, different LLM assistants, different LLM agents. And I think the killer app is really agents, if I'm honest. I think that's like the holy grail of where we're going. And these agents need to be built on top of LLMs. Like we've had agent frameworks for a really long time now. People built really convincing agent frameworks back in the 50s. But what was missing was the engine that allows, reasoning, learning, personalizing on the fly, all these sorts of things. And now we have that engine. And so now all of these old ideas about like agent frameworks come back into play, and we can experiment with all of them again.
Okay, I have another one from one of our community members, Peter Amafidon. Peter asks, hi, Richard, what future use cases do you foresee for reasoning engines, particularly in the context of crypto?
Yeah, that's a good question, actually. I think like reasoning is like really general. And so the question is, what is the most valuable thing that we can do with reasoning? And it's probably to generate like business value, I would say. I've been diving into the literature on like business processes, business workflows, and thinking about how we can use reasoning in a lot of these. So I think, just like in a lot of different processes that we do day to day, maybe like making decisions about things, all these sorts of things are really interesting, especially for DAOs, right?
Great answer. Okay. So we have about 2 minutes, so we'll use the time to welcome everybody who's just joined. Thank you very much, Richard. It was great to hear from you again. And it's really cool to keep diving even further into this stuff. I like how we're building on what we've already talked about. So thank you very much for that.